In question 4a, we're told that the circle C has equation x minus h all squared plus y plus 3 all squared is equal to 12. In part I, we must write down the centre and radius of the circle. There is a result from the formula book which will help us out here. If we let h, k be the centre of the circle and r be the radius, then the equation of the circle will be x minus h all squared plus y minus k all squared is equal to r squared. Matching this formula with the equation we were given, we have a h in the slot of the h. We have a plus 3 in the slot of the minus k, and we have a 12 in the slot of the r squared. This gives us three equations. H is equal to h, minus k is equal to plus 3, and r squared is equal to 12. Changing the signs of both sides, minus k equal to plus 3 implies that k is equal to minus 3. Square rooting both sides, r squared equal to 12 implies r is equal to the root of 12. This means that the centre, h, k, comes out as h, minus 3. And the radius, r, is equal to root 12. In part 2, we're told that the perpendicular distance of a given line to the centre of the circle C is 5 units. We need to use this to work out two possible values of h. This question involves a perpendicular distance. The first step will be to open up our formula book and look this up. There's a result that says the perpendicular distance from the point x1, y1 to the line ax plus by plus c equal to 0 is the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. We're told that the perpendicular distance is 5 units, so we should set this expression equal to 5. The line that we're given can be written as 1x minus 4y plus 7 is equal to 0. The point that we have is the centre of the circle. In the previous part of the question, we found that this was h, minus 3. In the formula, a refers to the number in front of the x. So here, a is 1. B is the number in front of the y, so here b is minus 4. C is the constant term, so c is equal to 7. x1 and y1 refer to the coordinates of the point, so here x1 is h and y1 is minus 3. Let's sub these values into our formula. From here we can simplify. 1 times h is h. Minus 4 times minus 3 is plus 12, and then when you add on the 7, you get plus 19. 1 squared is 1, and minus 4 squared is 16, so underneath the square root, we get 1 plus 16, which is 17. We can get rid of the fraction on the left if we multiply both sides by root 17. This tells us that the absolute value of h plus 19 is equal to 5 times the root of 17. The absolute value of the positive and negative versions of a number both come out to the same thing. So there's two options for the expression inside the absolute value. Either h plus 19 is equal to plus 5 root 17, or h plus 19 is equal to minus 5 root 17. Focusing on the first case, subtracting 19 from both sides gives us h is equal to plus 5 root 17 minus 19. In the second case, subtracting 19 from both sides gives us h is equal to minus 5 root 17 minus 19. So there's the two solutions for h. In part B, we have a diagram of a circle S. We're given 3 points which are on the circle: A3, A minus 5, and 8, 1. We're also told that the radius of the circle is equal to root 20 units. We must use this information to find the equation of the circle. A very useful fact here is the following. If you draw a vertical line through a circle, the y value of the centre will be halfway between the y values of the two intersection points. Two of the points that we were given, a, 3 and a, minus 5, share an x value. This means that if we drew a vertical line at x equal to a, it would intersect the circle at these 2 points. Using our fact, we can deduce that the y value of the centre of the circle will be halfway between the y values of these 2 points. In other words, it will be halfway between 3 and minus 5. We can find this halfway point by adding together the numbers and dividing by 2. This gives us 3 plus minus 5 all over 2, which comes out as minus 1. We've shown that the centre of the circle has a y value of minus 1. This means that the coordinates of the centre are in the form h, minus 1 for some unknown value of h. The radius, r, was given to us directly. R is equal to root 20. We were asked to find the equation of the circle. It'll be a good idea to sub these values into the equation of a circle formula. X minus h all squared plus y minus k all squared is equal to r squared. H is still unknown, so we leave it as it is. K is equal to minus 1, and r is equal to root 20. Minus 1 is plus 1, and root 20 squared is 20. So we end up with x minus h all squared plus y plus 1 all squared is equal to 20. We've made good progress here, but we're not quite done. We still need to find the value of h. To do this, we'll use the fact that 8, 1 is on the circle. Any point on a circle must satisfy its equation, so this means we can sub in x equal to 8 and y equal to 1 into the equation of our circle. From here, we can do some algebra to solve for h. 1 plus 1 is 2, and when you square 2, you get 4. The plus 4 on the left can be removed if we subtract 4 from both sides. 20 minus 4 is 16. The square on the left can be removed if we square root both sides. We have to be careful and write in a plus-minus sign here. This is because the positive and negative versions of a number both square to give you the same answer. The root of 16 is 4. To deal with the plus-minus sign, we should split into two cases. In the first case, we replace it with a plus, and in the second case, we replace it with a minus. Let's focus on the first case. 8 minus h is equal to plus 4. Here, I'll subtract 8 from both sides. Observe that 4 minus 8 is minus 4. And then change the signs of both sides. This gives us h is equal to 4. In the second case, we have 8 minus h is equal to minus 4. Here, I'll subtract 8 from both sides. Simplify minus 4 minus 8 to minus 12. And then change the signs of both sides. This gives us h is equal to 12. We've gotten two solutions for h, but only one of them makes sense in the context of the question. If you look back at the diagram, you'll notice that the centre of the circle must be to the left of the point 8, 1. This means that h, the x-coordinate of the centre, must be less than 8. This rules out the h equal to 12, so we conclude that we must have h equal to 4. To get our final answer, we should write this in to the expression we had for the equation of the circle. This gives us x minus 4 all squared plus y plus 1 all squared is equal to 20.